Okay, class. Can see my screen?
Yes.
Huh? No?
Yes.
Okay. Okay, class. Today we will discuss on tutorial 3. I have uploaded this slide in Microsoft Teams. So today we will discuss tutorial 3, number 1 until number 5 only. Okay, so number 1, the current through a meter movement is 150 microamp peak. So the given value is in peak value or maximum value. What is the DC value if the instrument use half-wave rectification? The answer is given. So DC value or the value shown by the meter, the DC meter is in average value or DC value. So we know that average value for half wave rectification is equal to 0.318 of peak value. So now it is current, so I average or IDC is equal to 0.318 IM. IM is maximum or I peak. Okay, so equal to 0.318 150 micro equal to 47.7 microamp. That's all.
Doktor. Doktor nak tanya, kalau saya guna 150 mikro bahagi dengan set 2, lepas tu dapat jawapan and then saya darab dengan 0.45. Boleh kan?
Sama kan dapat?
Dapat 47.7 lah. Nak confirm kan?
So you will get the same answer. Okay. Because the formula half-wave rectifier. Okay, so the formula is VRMS is equal to V peak over Z2. Okay, and then you divide it with pi. Yeah.
Tak. Kira first tu 150 mikro bahagi dengan set 2.
Okay, divided with Z2 so that you get IRMS kan?
Ya betul. Lepas tu
okay,
saya nak convert ke DC, so darab dengan 0.45.
Okay. Times 0.45. Okay, so the average value is equal to 0.318 peak value or equal to 0.45 RMS value. Okay, so since the given value here is peak, so we just use the peak value. Or you want to convert it into RMS. Okay, so you just take this value divided with Z2. Sekejap, confused pula I. So 150 micro, this is peak value. Lepas tu you divide with Z2 kan?
Betul.
And then You dapat ni dalam RMS. Okay, and then you multiply with 0.45 kan? Okay, so any question from others? No question. Number 2. Okay, the unsupermeter movement deflects to 0.8 milliamps. What is the peak value of the alternating current if the instrument use full wave rectification? So the question is to find peak value. Okay, so we know that average value is equal to this, since this is full wave rectification, so average value is equal to 0.636 of peak value. Okay, so this one is equal to 0.8 milli because the unsupermeter movement shows average value or DC value, so equal to 0.8 milli. So now we want to find the peak value. Peak value is equal to 0.8 milli divided with 0.636. We get 1.258 milliamps. Okay, can I understand? Okay, the next question is number 3. Draw and design an AC voltmeter using half-wave rectifier for a 30 volt VRMS range. The observable movement with an internal resistance of 500 ohm and full scale current of 1 milliamp is used. Calculate the AC and DC sensitivity. So draw and design. So we draw. This is AC voltmeter. Half-wave rectifier meaning that we put a diode for a 30 VRMS range. So the V range is 30 VRMS. The unsolvable movement has internal resistance of 500 ohm, and the current flows is 1 milliamp. Calculate DC and AC sensitivity. So we draw first and then design. Design meaning that we have to find RS. Okay. So calculate AC and DC. So let's find SDC. SDC is equal to 1 over current. Okay, 1 over 1 milli equal to 1 kilo ohm per volt. SAC is equal to 0.45 SAC because of half wave rectification. So 0.45 multiplied with 1K, we get 450 ohm per volt. Any question? No. Okay, the next is to find RS. RS is located here. So we know that this is series circuit. We have RS and RM. So R total is equal to RS plus RM. R total is equal to VDC divided with current. VDC is 0.45 V RMS because of half wave rectifier divided with current. So RS is equal to R total minus RM. R total is equal to VDC over current or 0.45 VRMS over current minus RM. So we substitute VRMS is equal to 30 divided with current 1 milli and minus RM 500. RS is 13 kilo ohm, or this is the shorter way. R total is equal to SAC V range AC or SDC V range DC. Okay, so SAC is equal to 450. V range of AC is equal to 30. And then this is our total. So how to find RS? R total minus RM. We get the same. Okay, any question?
No.
Okay, this is number 4. Draw and design an AC voltmeter using full wave rectifier for a 50 volt peak to peak sine wave range. This unsolvable movement with an internal resistance of 100 and full scale current of 200 microamp is used. Calculate the AC and DC sensitivity. So we draw AC voltmeter. We know that to create AC voltmeter from the ensemble, we should add rectifier. So for full wave rectifier, we should have 4 diodes here. Okay, so 50 V peak to peak is the sine wave signal. Internal resistance of the ensemble is 500 here, and current is 200 micro. Okay, calculate the AC and DC sensitivity. So we have draw the circuit. How to design? We should add RS. So now we want to calculate RS and then AC and DC sensitivity. Okay, now let's start with SDC. SDC is equal to 1 over current, 1 over 200 micro. We get 5 kilo ohm per volt. Okay, so SAC is equal to, because of full wave rectifier, so 0.9 SDC, 0.9 multiplied with 5K, we get 4.5 kilo ohm per volt. And then we should find RS. Okay, SDC and SAC have been calculated. R total, okay, so how to find RS? RS is equal to R total minus R of diode and Rm. Okay, so R total is equal to VDC over current is equal to 0.9 VRMS because of full wave rectifier divided with current. So 0.9 multiplied with VRMS. So VRMS, 50 volt is V peak to peak, meaning that from the bottom to the top of the signal. Okay, so V peak here is equal to
25.
25. So V peak is 25. How to find VRMS? VRMS is equal to V peak over Z2. Okay, so 25 divided with Z2. Okay, and then current is 200 micro. 200 micro minus 500 because of this is Rm. Okay, so we get 79K. Or you can use the formula of S multiply with V range. Okay, so Rs is equal to S AC multiply with V range AC. Okay, so if you use DC, so V range DC here. But now this is AC, and then we minus Rm. So SAC is equal to 4.5K multiply with V range AC. Okay, same with this 25 divided with Z2 and then minus 500, you get 79K. Any question? Okay, this is number 5. Calculate the AC and DC sensitivity and the value of the multiplier resistor required to limit current to the full scale deflection current in the circuit shown in figure 1. This is figure 1. Calculate AC and DC and then find RS. Okay, so let's find SDC. SDC is equal to 1 over current. I total is equal to. Okay, so let's redraw the circuit. Since this is open circuit here, current cannot flow here. So we have RS and the RD, R1 and then Rm. Okay. So 1 over current, we know that here is 1 milliamps, 250 ohm here and 250 ohm here, meaning that current flow through the meter 1 milli as well as current through R1. So 1 milli here, 1 milli here, so total current is 2 milli. Okay, so I total is equal to 1 milli plus 1 milli equal to 2 milliamps. SDC is equal to 1 over 2 milliamps, we get 500 ohm per volt. Okay. So, okay, this is AC, and then this is AC signal. Okay. Okay, SA, and then SAC is equal to 0. Okay, SDC is equal to this. SAC is equal to 0.45 SDC because of half-wave rectifier. Okay, when we look at this figure, this is half-wave rectifier because we have only one diode. Okay, full rectifier has 4 diodes. Okay, so 0.45 SDC. SDC is 500, so SAC is equal to 225 ohm per volt. And then RS is equal to R total minus, okay, so we find R total first. R total is equal to V over I, VDC over I. VDC is equal to 0.45 multiplied with VRMS. So 0.45 multiplied with 20, as given in the circuit, in the question, divided with 2 milli. Okay, so R total is equal to 4.5 kilo ohm per volt. Okay, so 4.5 kilo ohm per volt. We know that R total is equal to Rm parallel with R1 and then add with Rd and Rs. Okay, Rs is equal to R total minus Rd minus equivalent resistance of R1 and Rm. Okay, so we substitute R total 4.5k here minus Rd. Rd is given in the circuit 300 ohm minus 250 parallel with 250, we will get half of this value. So Rs is equal to 40.75 ohm. Okay, any question? Any question?
Betul.
Mm-hmm.
Kan untuk nombor 5 kan?
Mm-hmm.
Kan ada yang RD 300 ohm, lepas tu R1 250 ohm apa semua tu kan? Sebenarnya RD yang 300 ohm tu tadi kita memang tak pakai langsung lah.
Yang mana?
Yang 300 ohm tu.
300 this one?
Ya.
Because when current flows from the supply, okay, so current will flow through this RD, but not the other RD because of, okay, this diode cannot conduct, okay, because it is reverse bias. Okay, as you learn last semester during subject principle of electronic kan. So this diode is in reverse bias, so it cannot conduct current. So current will flow from this through this RD only. Okay, menjawab tak soalan? Okay tak?
Okay doktor, okay.
Any question? Any other question? Any other question? Okay, let's try number. I think we can stop here. Next week we will continue tutorial 3. We have 10 questions total. The total question is 10 questions. So today we done half of the tutorial 3. Next week we will continue. Is it okay?
Okay, doktor.
Okay, doktor.
Our quiz 1 will be